Quantum mechanics is the highly probabilistic theory. In quantum mechanics, we always deal with probability, and we describe every event with probability amplitude. Probability amplitude phi, and remember, square of this probability amplitude is the probability of certain event p. And what is phi? Phi is nothing but a function of space and time in quantum mechanics. It is identical to the position x t in classical mechanics. So phi xt tells about the probability amplitude of certain event in quantum mechanics. Now pay attention to the two-slit double slit experiment. In double slit experiment, there is a electron gun which can fire a electron, and electron either can go through hole 1 and hole 2 and end up at screen X. Now we can describe this event of electron going through hole 1 to X and electron going through hole 2 to X with the help of probability amplitude. So probability amplitude of electron going through hole 1 and ends up at X, we can describe probability amplitude as phi 1 equal to as source first hole from first hole to screen X. This is the bracket notation. Again, if electron is going through hole 2, we can describe probability amplitude phi 2 is equal to X to S. This is the probability amplitude of electron going through hole 2 to X. Now, suppose we want to know whether the electron is going from hole 1 or hole 2. How we can judge whether the electron is going from hole 1 or hole 2? We simply put a light source behind the wall. We know that electron can scatter photon. And to catch photon, we have placed a detector D1 and D2. If electron has scattered a photon from the hole 1, then we can detect the photon at detector D1. And if electron has scattered a photon from hole 2, then we can detect the photon at D2. Suppose take case 1. In case 1, suppose electron has traveled through hole 1 and it has scattered a photon, and photon has gone to detector D1 and electron has gone to X. Then what is the probability amplitude of photon going to D1? Suppose the probability amplitude of photon at D1 is A. Then total probability amplitude will be X1 A 1S, which is A phi 1. This is electron is going from hole 1, photon has scattered at detector D1 and electron has gone to X. Same way, there is a certain probability that electron will go to hole 2 and it will scatter a photon, which photon will be end up at D2, not D1, because in quantum mechanics there is a probability of every event. So in that case, the photon will end up at D2, the probability amplitude will be B, and total probability will be X to B to S or B phi 2. This is the probability amplitude of electron going through hole 1 and photon has scattered at D2. So total probability amplitude will be A phi 1 plus B phi 2, and in that case electron from the electron from S and photon from the light source L, and same way electron at X and photon at D1. This is the probability amplitude A phi 1 plus B phi 2. Again, suppose, so this is the total probability amplitude of electron going through hole 1 and hole 2, and also electron photon is ending up at D1. So A phi 1 B phi 2. So E from S, photon from L, and electron XX and photon at D1. This is the probability amplitude of event when we have detected only photon at D1. Now we can reverse the role. Suppose electron is going through hole 1 and he has scattered a photon, and that photon had end up at D2. Again electron has gone through hole 2 and it has scattered a photon, again D2. In that case electron has reached at X1, photon has detected at D2, E from S and photon at L. It is B phi 1 plus A phi 2. This is the probability amplitude. Again I repeat this again. In case 1, this is case 1. In case 1 we have simply described the probability amplitude of electron going through hole 1 or hole 2 and reaching at X. It is phi 1 and phi 2. Phi 1 for the hole 1, phi 2 for the hole 2. In second case we have placed the light source behind the wall so that we know whether the electron is going from hole 1 or hole 2, and electron can scatter a photon. To detect a photon we have placed detector D1 and D2. Again suppose electron has gone through hole 1, it has scattered a photon at D1 and reached the screen X. In that case A phi 1 is the probability amplitude. Again electron has gone through hole 2, again it has scattered a photon, but that photon has ended up again at D1. So the probability amplitude is B phi 2. Total probability is A phi 1 plus B phi 2. Now take the third case. This is second case. Third case will be electron has gone through hole 1 or hole 2, but photon has ended up at detector D2. So it will be B phi 1 plus A phi 2. We have reversed the probability amplitude. Now total probability amplitude will be square of all these terms. A phi 1 B phi 2 square plus B phi 1 plus A phi 2 square. Now suppose A is equal to B. In this case A is equal to phi 1 plus phi 2, or it will become 2A square phi 1 plus phi 2 whole square. This is the total probability amplitude, total probability of electron going through hole 1 or hole 2 and end up at X. If the probability amplitude of detecting a photon at D1 and D2 is A equal to B.